Welcome to AI Frontiers. Today we present the cutting edge of machine learning, spotlighting key advances and insights from 132 research papers published on May 29, 2025, and classified under the cs.LG category on the arXiv preprint server. This episode explores trends, methods, and future directions, focusing on model alignment, efficiency, robustness, and more. AI Frontiers delivers expert synthesis, offering a comprehensive view of the latest breakthroughs in machine learning. This guided journey through contemporary machine learning research will unpack dominant themes and research approaches, delve into 3 seminal papers shaping the field, and illuminate key findings that hold real-world significance. Listeners can expect to understand emerging challenges, discover future directions, and gain both a broad and deep perspective on the progress within machine learning today. In 2025, machine learning stands at the heart of modern artificial intelligence. It encompasses the development of algorithms that learn from data, powering technologies such as speech recognition, computer vision, healthcare diagnostics, and more. The field intersects with statistics, optimization, and computer science, and models are now capable of processing text, images, audio, and scientific data. Research efforts are directed toward creating systems that are smarter, safer, and more adaptable to a range of complex tasks. The first major theme is model alignment and preference optimization, which focuses on ensuring that machine learning models reflect human values and intentions. Aligning models to human feedback has become increasingly vital as systems are deployed in real-world settings. Methods such as preference optimization and reward modeling are advancing the state of alignment. One and colleagues provide information-theoretic foundations to guide the design of better alignment objectives, while Goltz and collaborators emphasize the need for pluralistic strategies to address the diversity of user preferences. These innovations support both fairness and practical deployment of aligned systems. A second central theme addresses efficiency and scalability at scale. As models become larger and more complex, efficient training and inference have become essential. Distributed training introduces bottlenecks in communication and memory usage. Therian and colleagues demonstrate that the muon optimizer can achieve an 8-fold reduction in communication overhead during training, while Lowe and co-authors present memory-efficient fine-tuning methods that preserve pre-trained knowledge. Such advancements are democratizing access to powerful models, enabling broader participation in large-scale machine learning. Robustness, fairness, and safety form the third theme. Models must withstand distribution shifts and adversarial manipulation, especially in sensitive domains like healthcare, finance, and security. Vlonsu and co-authors highlight biases in medical artificial intelligence and propose mitigation strategies, while Halloran introduces algorithms for safe refusal and secure handling of harmful or deceptive user requests. Trustworthy artificial intelligence remains a top research priority, with ongoing efforts focused on ensuring models are robust, fair, and safe for deployment. The fourth theme encompasses interpretability and architectural innovation. The increasing complexity of machine learning models has heightened the demand for transparency and explainability. Furman and colleagues propose model-agnostic counterfactual explanations, enhancing interpretability across diverse applications. She and collaborators advance unified diffusion transformers, capable of processing both text and images, paving a way for multimodal reasoning and more insightful model behaviors. These developments foster user and domain trust by making model decisions more understandable. A technical highlight in recent research is the application of information-theoretic principles to preference optimization. Information theory clarifies the design of optimal reward functions in model alignment. The concept of differential information distribution, introduced by Wan and colleagues, measures learning progress and reveals why log ratio parameterization is uniquely effective for aligning models with human feedback. This framework guides the creation of better datasets and training regimes, bridging the gap between empirical practice and foundational theory. Critical insights have emerged across the field. Wan and colleagues demonstrate that information-theoretic foundations optimize preference alignment, providing a principled basis for designing objectives. Therian and co-authors introduce new optimizers that dramatically reduce distributed training costs. Goltz and collaborators reveal that standard alignment techniques can fail in the presence of diverse user preferences, but Nash learning offers a robust alternative. She and colleagues show that unified, efficient multimodal generation is now possible, and Levin and co-authors advance cross-dimensional transferability, enhancing model generalization. Several methodological strategies are driving progress in machine learning. Preference-based reinforcement learning aligns models with user intent, while information-theoretic analysis uncovers optimal learning objectives. Parameter-efficient fine-tuning techniques conserve computational resources, and communication-efficient distributed training enables scalable model development. Additionally, counterfactual and curriculum learning approaches foster greater explainability and improve generalization, each with distinct trade-offs and strengths. The first seminal paper, Differential Information, an information-theoretic perspective on preference optimization by Wan and colleagues, provides a rigorous theoretical foundation for the use of log ratio rewards in model alignment. The introduction of the differential information distribution concept links the structure of preference data, the learning objective, and the behavior of the resulting model. This framework is validated through both synthetic and real-world tasks, and is recognized for effectively bridging theoretical insights and practical alignment strategies. The second seminal paper, Distortion of AI Alignment, Does Preference Optimization Optimize for Preferences? By Goals and collaborators, analyzes the limitations of current model alignment methods for diverse user populations. The concept of distortion is introduced as a new metric for evaluating user satisfaction. The authors propose Nash learning from human feedback, a minimax optimal method, and demonstrate that standard approaches often fail to maximize average utility in pluralistic settings. This work advances the development of fair and robust alignment strategies. The third seminal paper, MuLoco. Muon is a practical inner optimizer for DLoco by Ferrien and colleagues, addresses the communication bottleneck in distributed training of large language models. By integrating the Muon optimizer with compression techniques and error feedback, the system achieves an 8-fold reduction in communication volume without degrading model quality. This approach enables broader access to large-scale language models and represents a significant step forward in practical, scalable model training. Looking ahead, several future directions are evident. Research is focusing on developing context-aware and pluralistic alignment methods to better account for user diversity. Deeper integration of information theory into model training is anticipated, along with the expansion of unified, efficient architectures for multimodal tasks. Advances in communication efficiency are expected to broaden access to large-scale models. Additionally, there is a continued emphasis on prioritizing reliability, safety, and interpretability in real-world deployments. This analysis was synthesized using GPT 4.1 by OpenAI for content generation, with DeepGram text-to-speech employed for audio narration and Grok for image concept design. Every summary and slide underwent expert human review, though some oversights may persist despite careful attention. Full references to all cited research papers are provided to ensure transparency and facilitate further exploration. Stay informed with AI Frontiers. Here, the latest developments in machine learning and artificial intelligence are delivered directly to you. Subscribe to our YouTube channel for deep-dive episodes and join a community of researchers, practitioners, and enthusiasts. Benefit from expert synthesis, timely paper highlights, and insights into future trends. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, complex research is made accessible so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.